Hey guys, welcome back. In this session, we'll be looking into how we can configure how do we actually use VPNs in a ASA environment, right? If you look at the topology on the left, we have four routers: R1, R2, R3, and R4. You can assume R3 to be like the branch router on the other side of the internet. You can consider R2 to be like the actual internet, right? It's simulating the internet, and R1 ASA is basically inside the organization, and R1 to be the internal network of the organization, and R4 to be the DMZ zone of a org, right? Now the main objective of this session is we are going to establish VPN between R3 and R4 and R3 and R1, right? R3 and R4 is going to be a little bit of a straightforward because it is going to be like a LAN to LAN VPN with since R4 and R3 both of them seem to have public IP addresses, so they can easily reach out to each other. But if you look at R1, it seems to be inside the net organization, so it has just private IP addresses. So we'll be looking into how we can use NAT to solve this problem for us and establish VPN between or the tunnels between R3 and R1, right? So that's the whole idea of this exercise. Okay, now we will start with the basic configuration. On the right hand side, I have my topology, I have my physical devices. I have to basically convert this physical network into this logical network. And how do we do that? We have been doing it using VLANs, right? So if you look at top here, so all of the devices are connected to the switch, and what we gotta do is, if you start from the top, right? If you start from the top, we have routers R3 and R2, and both R3 and R2, the interfaces, the 0/1 interfaces of both the routers has to be in VLAN 23, right? So if this is my R3 and this is R2, so you see the Ethernet 1/0 over here is similar to the 0/1 here. So 1/0 of this and the 1/0 of okay, give me a minute. Yeah, so one of the interface of R3 and one of the interface of R2, both of them have to be in VLAN 23, and the network is going to be 192.123.0, right? So let's start with configuring that. Let's go to my switch. So this is going to be, I'm going to start with configuring the switch, right? Okay. So this is needed because we are going to otherwise have a lot of errors regarding duplex settings, right? So we're going to just make all the ports go under duplex. Now, like I said, let's start with the VLAN 23. So VLAN 23 is here, and we need to put F1/3 and F1/5, right? Okay, 1/3 and 1/5 in VLAN 23. So let's do that. Right, good. Next is we have VLAN 20. Do we have VLAN 20 here? Yeah, we have VLAN 20 here. So what we got to do here is we need to put one of the interface of R2, which is F1/2, and the ASA interface as well, which is F1/6, right? The outside interface over here is 1/6, which is corresponding to E0 here is 1/6. So we're gonna put 1/2 and 1/6 in VLAN 20. Okay, that's the second part. Okay, you're done with that, and we go down to the next VLAN, which is going to be VLAN 40, right? And VLAN 40 is going to have one of the ASA interface, right, which is going to be 0/2. So let's take this, which is 1/8, and the R4, which is 1/4, and 1/4 and 1/8, they go inside VLAN 40. So let's put that as well. And the last one is VLAN 10, which is over here. So one side of the ASA and the one side of the router, right? They go down in VLAN 10. So which means it's 1/1 here and 1/7, right? The outside interface, yeah, inside, sorry, yeah. So that's it. That's basically my VLAN configuration on my switch, right? Let's probably quickly put this up right now. Let's pick this configuration and put it up on the switch right now. Okay, this is my switch. Let's clear this a bit. There you go, and that is where I paste it. Okay, so I think that's good. We have that. Let's see if everything went right. To show VLAN switch should work. Okay, looks like we have two interfaces in 10, two of them in 40, 23 and 20, right? Great, wonderful. So we have all of this up, all the routers are up. Okay, so we have the switch configuration done. What do we do next? Right, so we have done the switch. We will move down to the routers now. So we'll start with router R3, right? What do we have to do on R3? Okay, so on R3, let's do the configuration of the interface IP address and probably put a loopback address and also maybe a default route towards towards R2, right? Probably we can do that. Okay, so let's do that. Let's pick this up. I already have the configuration up here, so I'm gonna directly paste that here and explain to you guys. So you can see R3 here. I have the Ethernet interface 192.1.23.3 right over here. Right, so this is going to be that network 23.3, and I'm going to put a loopback address as 10.3.3 3.33, right? So that's here, and a default route as well, which will be towards my R2, which is this interface. Okay, and I think that should be good. That should be my R3 configuration. Okay, R3 is done. Let's put it here. So once R3 is done, probably let's go one step down and do the next part, which is R2, right? So on R2 we are going to have two interfaces to be configured, 0/1 and 0/0, right, in the respective IP subnets is what we have to do. So let's do that, and let's also put a default route. Maybe not now, let's do only so much for now. Let's do just the two interfaces. Okay, so that basically comes here, right? Looks good. So we have R2 with 1/1 interface, which is going to be R2 1/1 is this one. Just forgive my naming convention. 0/1 is supposed to be 1/1. So the 1/1 would have 23.2, right, because it's part of this network, and the other side is 20.2, right, which is this one. So let me pick this up and put it as well on my R2 here. Okay, there you go. That looks good, right? Looks good. So we have R2 done as well. Let's probably check the connectivity between R3 and R2, right? So let's go to R3. Let's clear the screen a bit. So probably if I do ping 192.1.23.2, will this work? Yeah, that worked, right? So that's good. Okay, that looks good. So what do we do next? Let's go down and what do we have after R3 R2? We have the ASA. So let's configure the ASA. On the ASA, we intend to configure the interfaces now, right? So we need to configure the outside interface, inside interface, the DMZ interface 1, 2, 3, and probably put a default route to R2, because this is the internet. You have to point it to outside, right? So let's do that. So that should be pretty simple as well. So let's start with that. ASA, let's first put the three interfaces. Let me put the three interfaces here, right? So it's ASA and the gig outside interface. We're going to put an IP address of 192.1.20.10, right? The reason is because it belongs to this network 192.1.20.10, right, this part, and the DMZ will have 192.1.40.10, right, that it's going to be my DMZ, and the outside will have 10.11.11.10, right? So that's going to be my inside network. So these are the three. Let's also put a default route towards where? Towards my R2. So it's going to be route outside 00192.1.20.2. Looks good. Yeah, looks good. So let's pick this up and put it on the device, which is ASA over here. Yeah, so go to configure T mode, right, and we will drop our configuration. Okay, there you go. Looks good, right? Now we'll come one more step down. So we did ASA, we have to do R4 and R1. So on R4 again we need to do the Ethernet interface here, loopback address and a default route towards ASA. So let's do that. Let's do R4 now. This is my R4 here. So it's going to be Ethernet interface 192.1.40.4 because that's the network here. The default, sorry, the loopback address is 10.4.4.4 and the default route is 192.1.40 and 10. Right, this is in that interface 192.1.40 and 10. Right, makes sense. So that's my R4. So I take this, I go and put it on my R4 here. Okay, looks good. Yeah. Alright, so we have done with R4 and the last one which is remaining is my R1 configuration. So on R1 again we put interface, loopback address and default route towards my ASA. Right, pretty much same what we did in R4, we are going to repeat it in R1 as well. So let's do that. So you have the Ethernet interface 10.11.11.1 because it belongs to this network, and the loop packet is basically 10.1.1.1 and the default route is 10.11.11.10, right, towards ASA1. Okay, I think all of that looks good. Yeah, so I think we can test it. We can test the connectivity of R4 if you want. Maybe we can see. Okay, this is my R4. So if we do like ping, if we do a ping from R4 to probably the ASA, let's see if this works. Yeah, that worked. Right, so that's good. So we have done all the basic configuration now on my R1, R2, R3, R4 and the ASA. Now comes the interesting piece. What we are actually trying to do is we are trying to establish a VPN. The first one is between R3, R4 and the second one is R3, R1. So let's start with the R3, R4 configuration, right? So since my ASA is kind of like the, since my R2 represents the internet, let me put a, static route for now. I mean, I can anytime run a, IGP, but I can always run a routing protocol, but for now I'm going to just use a static route, and the static route is basically going to be on R2, and it will tell R2 how to reach my R4, right, because currently there is no connection, so I need to put some static route. So we'll do that first before we forget. So we go to R2 here. So the static route is going to be pretty simple like this. So it's IP route 192.1.40.4 255, this network, right, which is R4's network. How do you reach that R4 network? Using the next stop of 192.1.20.10, right, which is the ASA, right? So this is a static route. So let me pick this up and put it right now on R2. Okay, looks good. Okay, let's clear the screen also as well. Sweet. So we have done that. Next, what do we do next? Now comes the VPN configuration, which we have done a lot in my earlier videos, right? The LAN to LAN VPN, and note that we want the VPN between R3 and R4, right? So let's start writing. So let's start doing it on R3 first, right? So step one in any VPN is what? The phase one, right? So let's do the phase one to start with. Here you go. This is phase one. In the phase one, you define ISACM policy, put a number to it. The authentication is what you define. it's a pre-shared key, so this is the key which you're going to use, Cisco 123, and the peer address is 192.1.40.4, which is R4, and the encryption is triple S, hash is MD5, and the group for Diffie-Hellman is 2. Okay, so once you're done with phase 1, the next is phase 2. Okay, the phase 2 is basically crypto IPSec transform set, and you need to define triple S and MD5. You can use any other algorithms as well. For now I'm using these. Step 3 in defining IPSec is you need to define what is your interesting traffic which you want to be encrypted. So that's here. So I'm telling my R3 that any traffic which follows this particular rule, where the source is basically 10.3.3 and it is going towards 10.4.4 network, then you need to encrypt it. Okay. Now how do we combine all this step 1, 2, 3 in one set? It's basically using cryptomap. So cryptomap, we define a cryptomap, put a sequence number, IPSec ISACamp, and set peer is going to be 192.140.4 because that's R4, and we are basically setting the phase 2 whatever we defined, set transform set, and matching this with the IP address access list of 101. Okay, so once you have done all of this, the last step is we need to go and apply this on one of the interfaces, and in our case the interface is 0/1, or basically the 1/0 in my case. I mean, I've just replicated, I've just probably I'll put this up here. Yeah, so it's just 1/0, right? To use 1/0 on this. Okay, so that was basically the configuration on R3. Let me just quickly put this up right here. Okay, that looked good. Now for the VPN to work, obviously one side is not sufficient, we need to do it on both the sides. So the other side for this VPN tunnel is going to be R4. So let's go to R4 here. So most of this will remain same, so let me just copy this, right? Let's just copy this, go down to R4, paste it here. What will change? Phase 1, only this changes, which is 192.1. What is this network? 23.3, right? Here basically changes, and you need to reverse the ACL because it's for the other way around. Now the traffic is going from 4 going to 3, right? And change this as well, right? Let's change this here. Set peer also changes over here, and transform set, all of this is good, right? And I have applied it on the right interface as well. So yeah, that's basically what goes inside my R4. Okay, let's give it a minute. Still copying onto the device. Good. Okay, wonderful. So let's clear this screen here. Okay, so that was basically R4, right? We've done with R4, and what do we do next? Now we have done the configuration on R3, R4. Now the problem is ASA, right? Will ASA allow this traffic to flow directly? No. You know that any traffic which has to go from outside to inside, you need to write ACLs. So we need to write access list here to define certain rules which will allow the VPN traffic to actually flow freely, and that is what we'll do now, right? So we need to write ACL. So what ACLs will you write here? Well, you know that the phase 1 of VPN, so we'll go to ASA. There is ASA over here. Yeah, after this, here was where our ACLs will come. So we know that phase 1 basically uses which port? UDP, right? It uses UDP and port 500, and the second phase uses ESP, right? No port over here. So using this, using this information, we can actually create the ACL which we need. So what ACL will it be? It will be basically a very simple ACL, right? Outside, which will use the port UDP, Host is basically 192.123.3, means it starts from R3, right? Any traffic coming from R3 towards the host 192.140.4, right? With the port number of 500 because it's UDP, and the other one is ESP, right, for the same thing. So we are gonna allow this because we are applying this access list on the interface outside in the inside direction, right? So we take this and we put it on my ASA. Okay, looks good. We clear the screen a bit and let's test then once we've done that. Yeah, so we have done this. Okay, right, so this looks good. Now we will test it. So how do we test it? From R3, right? So what we have established now is we have established tunnel from R3 to R4. So let's test from R3 if this works. So let's go to R3. Let's do ping, audio ping 10.4.4.4. That's a loopback address of R4. Let's put a source which is going to be 10.3.3.3. Yeah, that worked, right? You can run it once again. Great. So which means the tunnel should have been up now, so we can check the tunnel. Clear the screen. So let's do show crypto, right? Crypto is the command, and IPSec if I'm not wrong, and it should be SEA, right? Great. So we have all the packets shown here, and you can also see that the tunnel has been established, right? Yeah, 10.3, 10.4, and this looks pretty good, right? The status is active and all of that, right? So that's good. So we have successfully established the tunnel between. So any traffic which is coming from R3 to R4 is getting encrypted now, right? The tunnel has been established. Now we'll go to the next task. So we are done with half of our objective. The next objective is basically we need to create the same tunnel from R3 to R1, right? And now we have to deal with the ASA. Not just the ASA, we need to deal with the IP addresses here being private addresses. Here it wasn't difficult because it was public address, but here it's private. Now the question comes as to when this is trying to ping, this is outside the internet. So when this device tries to connect to this device, it has to obviously use a public address, right? So we will have to do some kind of a NAT on my device here. But when you do the NAT, wouldn't you be breaking the hash, right, which normally happens in IPSec? So we have a solution for that, and we will see how we will configure this. So this is going to be fun, right? So R3 and R4, R1 is going to be the next piece. So we'll start with configuring what? R1 first. Let's do R1 first. We'll do this way now. We'll take R1 and configure it first. Okay. Yeah. So let's go to R1. Right, so let's go to R1. Do we have R1 here? Yeah, here. So we need to put VPN on this. Let's start with the same process. We will do phase 1. Okay, so we have phase 1. We put ISACM policy, auth pre-share, triple dash, MD5, group 2, and the peer is basically 192.123.3. Make sense? Because we are trying to connect R1 to R3, right? This tunnel. So the peer is 192.123.3. Phase 2 will remain same like last time. Looks good. Interesting traffic. Now the interesting traffic, the next step is basically the traffic which is flowing between 10.1.10, right, and 10.3.3.0 over here, the loopback of that. So we need to define that, right? So that's going to be my interesting traffic. Next is your crypto maps, right? Crypto maps. So crypto maps basically holds all of these things together. So we're going to define a crypto map, set the peer to be R3, transform set, and match address 101, right? The last part is we are going to apply this on an interface. There you go. So we applied all of this on the interface. So we are done with the configuration on R1. So let's pick this up. Let's go and dump it here. Good. Next, what we are going to do next is we will do the same configuration on R3, right? Because that is the other end of the tunnel. But we have already done some of the VPN configuration on R3 for the earlier tunnel, so we can reuse some of that piece as well, right? So let's do that. So for on R3 now, the phase one would be, I need not define the policy again because it's already there, right? I probably will have to define this ISACAM part once again. So let me do that. So I'll define only the ISACAM part because the peer address is going to change now. It's going to be 192.1.20.11, right? Because we are talking about this device, right? And this is it's going to be 20.11 because ASA is going to do NAT translation, right? So we will do that in a minute. Okay, so this is good. 20.11. What do we do next? Interesting traffic. I will tell you what it is. Why is it 20.11 once I go to the NAT part. But for now, just assume that this is the IP address of my R1, right? Interesting traffic. We need to define interesting traffic. Traffic coming in from 10.3.3 to 10.1.1, right? It is exactly the reverse of what we did earlier. Just reversing of the addresses. The last part is my cryptomap, right? Just that the cryptomap, the sequence number is going to be different here because we already have ABC10, so we are putting ABC20 here. And the peer is going to be again the address which we already put, which is R1. Set transform set and match address is 102. So we're going to use 102 because there is already 101 on the device. And this transform set, this cryptomap has already been applied on the interface, so we need not apply it again. So it looks pretty good, right? So that was basically the configuration which would go under R3. So we are done with R3, R1. Now what's remaining is my ASA. Let's go down to the ASA. There's my ASA over here, right? Now the problem is, what is the problem? We know that when so let me explain. So there is a feature. So there is a feature within IPSec. It's kind of like a automatic feature which is built in. It is called NAT Detector, right? Or NAT transparent. And what this feature does is it will try to detect, between any of the two endpoints, right? So if you're setting up IPsec between R3 and R1, it will try to detect if there is any kind of NAT happening. In this case, yes, there will be a NAT happening, which we will configure now, because we need to do it because this is the inside network. It's 10.11.0. I would not be able to access this private address from outside. So we need to do NAT here. We need to tell ASA that whenever packet goes from this 10.10, 10.11.11 network, you need to convert it into a public address. So we're going to do the NAT. Right now the problem is the ESP, right, the protocol which is used mainly in the phase 2 might have trouble with the translation. So because it is doing the translation, the hashing and all of that which happens might break, right? So what they introduced was they decided that they will introduce a new header which was UDP 4500, and all the data which was basically going would get encapsulated inside that, right? So now so breaking of hash will not take place, right, since the change in IP due to the translation, whatever is happening, will be happening in the outer header, and on the inside header all of the data will remain intact, so all the hashing and all of that will still work, right? So the basic idea here is that we need to allow UDP 500 as usual, because we were allowing it earlier as well. If you go back to my configuration here, right, we were allowing UDP 500 for the earlier tunnel as well, but along with that we will also have to allow UDP because the other way around, because the NAT is happening, right? So it will no longer be ESP, but the whole packet is encapsulated inside a UDP 4500 header. So we need to include UDP 4500 and UDP 500 in the access list. So that's going to be the only change here, main change, right? So let me put it here and maybe then you'll understand, right? So first we will have to put my NAT. I need to do the NAT. So I'm telling the ASA that when you see a packet for this host 10.11.11.1, please go and substitute or use this or translate it into this address 192.120.11 because it's a public address. Once the object group is put, now we go and define the ACL, right? ACL is basically here. So we're going to say access list outside permit UDP and 192.123.3, that's from R3 to R1. The EQ port is 500, and on the other side as well the UQ port is 4500, right? So looks good. So that's the only change. Now we will take this up and put it up on my, I need not apply this access list again because I've already applied it earlier. Okay, so we'll go and do this on my ASA. Okay, that looks good, right? I can check my access list if you want. So we have all the access lists here. Okay, great. Now how do we check if everything is working? We have to do the tunneling from R3 to R1. So let's do that. Let's ping from R3 to R1, right? So my bad, it's going to be ping 10.1.1.1. source is going to be 10.3.3.3. there you go, that works. So if I do show crypto IPSec SA, you can see that the tunneling has actually worked, right? You can see this, and you can also see the current peer, which is the IP address is 192.1.20.11, the translated IP address, right? Okay, so that means tunneling works. So what did we actually achieve here? We established tunneling between R3 and R4. It wasn't that difficult because we did not have NAT in place, but then we also achieved tunneling between R3 and R1, or VPN between R3 and R1, with your NAT happening here on the ASA, right? So hope you guys liked it, and tune in for more videos later. Okay, thank you.